In stats, we worked on some vocabulary and describing a scenario and worked a sampling distribution problem. So this first one uses two, well, definitely one, possibly two new words, and that is parameter and statistic. So before we start, the parameter, now this is all defined at the beginning of this packet, but let's just write it right here. This is the value found within the population, or for the population. I think that wording works. Statistic is the value from the sample. So two different measurements, same, if the subject is means or if the subject is proportion, that'll be the same, but we'll have a different group that we're looking at. So first of all, on this example, we're looking at a population of residential phones. It's actually typed right here. All residential, maybe we should write phone numbers. If I just write phones, that doesn't really make sense, right? Phone numbers in a city. So that's the group we're interested in, but the parameter, this is the true proportion of unlisted. So two different things that we're looking at here. They're kind of all in one, and we'll look at this in different ways over the next month or so, but this is P equal to 0.52. All right. They took a sample, and it was the first 100 numbers dialed. First 100 random phone numbers. And the statistic is the sample proportion of unlisted. Which is a different symbol and a different answer. P hat, and it was 48%, so 0.48. All right, take a look at that. Hopefully it's clear. Fix that 0 there. So we need to be able to distinguish between the population value, which is the parameter, and the sample value, which is the statistic. And we need to be able to describe it. So let's practice another one. And I'll warn you, there's a typo in the notes. I made it bold here. So it should say that. It says something different in the notes. It's like American, I have it right here. It says all adult American women. And I don't know, maybe it's trying to be a trick problem. I thought it was weird. So I just retyped it to this. So sorry for the typo in the notes, but it should say that. So the population is of interest is all female college students. And the parameter of interest is 63. So the true mean height which is mu equals 63. The sample, they don't tell us how many they took, but I do know it's a random sample of female college students. And the statistic is the sample mean height. And for that, we use X bar. And that was 64.5. So I hope everyone's clear why the true mean is 63 and the sample mean is 64.5. It truly does become a reading problem, and you got to pick it apart. So, all right, let's work we're not going to work a problem yet. We're going to look at the properties of a sample proportion sampling distribution. So the other day we looked at a Reese's Pieces computer program, and it created a sampling distribution. If we were to calculate by hand the mean of those sampling distributions, it would have been equal to the true proportion of orange candies. The standard deviation would be that true proportion times its complement divided by the sample size and then square root. This part right here, it's important and very true, but I'll be honest, I usually skip talking about that whenever I'm writing my answer to a problem. It's true and you can write it down, but to be honest, many times I don't see it in the rubric, so I brush past it. But the last thing on the page is super important. It's called the large counts condition. I know it's typed, but maybe rewrite it right here. Make it stand out. It is very, very important. If both of these inequalities are true, keyword both, then the sampling distribution is approximately normal. All right, so it's really important that you check this in order to proceed with the problem. Sometimes they'll ask the question, why can we not calculate the proportion and probability in question? And it's because maybe one of these doesn't check out, one of these inequalities right here. So both have to check out. Plug in N, plug in P, they both got to be greater than 10. All right, so let's work one. They tell us we're looking at first-year college students and how far away they are from home. They do an SRS of 1,500, and 35% of all first-year college students live within 50 miles of home. In the sample, 570 of them do. So the parameter is the true proportion P of first-year college students that live within 50 miles and we know it's 35%. The statistic is the sample proportion of 1,500 random students. And we already spelled it out. I think you can put a period on it there and write P hat equals 570 over 1,500. And I go ahead and calculate it because you'll have to eventually. So we know that that is 0.38, I believe. Yep. So this next paragraph right here is me attempting to describe a sampling distribution. You don't have to necessarily understand this, or sorry, this doesn't have to be typed in the problem to understand what they're asking for, but because this is our first sampling distribution problem, I felt the need to write this. So it's talking about how a sampling distribution in this scenario would be created. So it's when we do a sample of 1,500 students indefinitely, like a bunch of times. And then the required part that could be asked is to describe it. So I need to make sure I do the cuss thing. I need to describe the center. I need to describe the shape and the spread. All right. So for the center, I know that mu p hat is equal to p, that's at the top of this page, which is equal to the true proportion of 35%. That's our center. I just noticed I spelled spread spreel. Let's fix that. That one is sigma p hat equal to 0.35 times let's spell it out here. This is our first time doing it. I was going to write 0.65, but let's just plug it into the formula. And we get 0.123. That's our standard deviation. The shape, I'm kind of out of room in the middle there. I'm going to do that over here. So I know that 15, this is the large counts condition. I need to find if that is greater than 10. And I need to check if this is greater than 10. And I type it into my calculator, and sure enough, I get 525. And I get 975. Both check out. But it's not enough to just do that right there. I haven't described the shape. That just tells me what I need to say. I know that the sampling distribution is approximately normal. And now I've described the characteristics of that sampling distribution. All right, I know the center, I know the spread, or standard deviation, and I know the shape is normal. All right, so I have to scroll down, I have to erase this. They ask me a simple question, looks simple. Probability of these 1,500 students being 38% or more that live within 50 miles of the home. So I need to write the question. I already described the distribution above it, so I'm going to write that. And then I need to actually calculate. So I've already gotten points from what I wrote down. Be aware of that. Even if you're stumped on the probability, you still got points by just writing all that we've written already. So we said a second ago right here that the sampling distribution was normal, right? And if it's normal, can't I find the z-score of 38? Struggling with that 8. So it's the value in question minus the mean divided by the standard deviation. And that right there is why I really, really focus on you being able to do a z-score. Because the calculator won't be psychic and know what to do. If you do normal CDF, you'll forget how to do standard deviation. So this is one reason why finding the z-score is very important. Or you're just stumped. So now that we have the z-score, jump to normal CDF, and you type in 2.4390 for the lower, 999 for the upper. Let's just do it in case someone needs help. So normal CDF, 2.4390, a bunch of 9s, and OK. 0074. Ooh, 007 if we round to the third place. And that's it. So you got to do that, got to do that, and got to do that. You already described it, so I wouldn't count that on that part. All right, see y'all later. Bye.